Welcome back. This is Chapter 4 review, and this is problem number 2. And it's asking us to find all critical points. And so that's what we will do. I just want to point out in a reminder that, like for example, if I have something that's open interval, so in other words, it goes off to infinity and goes back to negative infinity without any boundaries on it, that setting the derivative of a function equal to 0 and solving algebraically will find all the critical points. Because when the tangent slope, or the derivative at a given point is 0, that must mean that it is either at a high point or a low point, or there's one more example. It could also be at what we call a saddle point, which is neither a minimum nor a maximum. That's where something flattens out and then it keeps going the way it was. So this is not a max or a minimum. This is a saddle point. This would be a maximum, and of course this would be a minimum. And I also want to point out that if an interval is given, like for example, let's say we cut off the graph here and here, and we don't go, so in other words, we don't have the full function. If there's an interval, we need to figure out the endpoints of the interval and figure out what kind of extrema they are. For example, this endpoint would be a local maximum because it's higher than everything else around it, and this would be a local minimum because it's lower than everything else around it. And you'll notice that these endpoints, their slope is not necessarily 0, like the other extrema. So if there would have been some sort of interval, like say from 0 to 8, you would always have to figure out what kind of extrema 0 was and what kind of extrema 8 was, because if there's an interval, the endpoints are always going to be extrema. So I just wanted to point that out before we hop into this problem, of which there is no interval, and so that makes it a lot less taxing because we just have to take the derivative and set it to 0. So we'll take f prime x, first d second, so x d second is using the power rule, 3 times 8 minus x squared. And then the chain rule, we have a minus x, so we take the derivative of the inner function, and that gives us a minus 1. So we'll multiply that on plus second, which is 8 minus x to the third, d first, which is just times 1. And so now we'll simplify it. F prime of x equals minus 3x, 8 minus x squared, plus 8 minus x to the third. Oh, I'm sorry, I wrote this wrong. 8 minus x quantity squared. So then we're going to set the derivative equal to 0, because as I said before, when the slope of the tangent line equals 0, you're at either a minima, a maxima, or a saddle point. And regardless of which 3 those are all critical points. And that's what this problem is looking for. So 0 equals 3x times 8 minus x squared plus 8 minus x cubed. And the important part here is to not destroy anything with the 0. For example, you could destroy everything with the 0, but you may lose some information. So in other words, we could divide by 8 minus x squared and destroy it on 0. And sometimes that'll work, but sometimes it won't. So it's important to realize that when you algebraically manipulate something, sometimes you'll lose information when we destroy something with 0. So what I'm going to do is I'm going to factor out an 8 minus x squared from both of these terms. So that will take 8 minus x squared out of negative 3x, 8 minus x squared. That'll take the 8 minus x squared completely out. And for this one, 8 minus x cubed, if we take out 8 minus x squared, we're just left with 8 minus x to the first. So we've successfully factored out an 8 minus x squared from both of these terms. And now at this point, we know that we've got a product here. It's this term times this term. If this term goes to 0, it will destroy this term, and then this will be equivalent. Where if this term goes to 0, it will destroy this one and they will be equivalent. So we just need to set either one of these products equal to 0 and solve for them. So minus 3x plus 8 minus x equals 0, and 8 minus x squared equals 0. So over here we get the minus 3x minus x minus 4x. We subtract the 8 over here, minus 8, divide by 4, minus 4, and we end up with one of our critical points is x equals 2. And then over here, we'll take the square root of both sides. So 8 minus x square root equals plus or minus square root 0. Remember, whenever we introduce a square root, we have to put plus or minus in front of it. And what we're left with is 8 minus x equals plus or minus 0. Well, plus 0 and minus 0 are both just 0, so we can get rid of the plus or minus. Then we'll subtract 8 from both sides, and we end up with minus x equals minus 8. And there we found another critical point, which is x equals 8. And that is all the critical points we have. You'll notice it's kind of interesting because this term here, 8 minus x is cubed. That means that it's actually taking up 3 of the zeros for the original graph. And it's also taking on quite a few of the zeros on the derivative. So normally if you look at something that's to the 4th power, so in other words we have an x to the 1st power and x to the 3rd power, that's a quartic equation. And normally that would have it normally would have 3 extrema, but because this one is repeated, we only get 2 extrema. One from the 8 minus x squared, or just the 8 minus x term, and one from this minus 3x plus 8 minus x equals 0 term. So I hope this was helpful, and I'll see you next video.